Here the question number third is consider two postulates given below. Here first is given any two distinct point A and B, there exists a third point C which is in between A and B. That is, there are two different points A and B and the point C lies between them. And second postulate is there exist at least 3 points that are not on the same line. Here the question is, do these postulates contain any undefined term? That is, any term that we have to define. Are these postulates consistent? Do they follow from Euclid postulate? Explain. That is, we have to give the answer. Undefined term, consistent postulates, and they follow or not Euclid postulates. Here there are undefined terms are the undefined terms are line and point. Now the next question is, are these postulates consistent? Yes, these postulates are consistent because these postulates represent two different situations. That is, consistent means these are unique. Here first postulate is there are 2 points A and B and another point C which lies between them. Then these 3 points on the same line. And the second postulate is that there are 3 points which are not on the same line, like this, A, B, C. Now next question are, do they follow Euclid postulate? No, these postulates do not follow Euclid's postulates, but they follow Euclid's axiom. That is, a unique line can be passed through two distinct points. For example, there are two different points, a unique line is only passes through them. Now the next question is question number 4. Here, if a point C lies between 2 points A and B such that AC equals to BC, then prove that AC equals to half of AB, explaining by drawing the figure. That is, we have to draw the figure. Here it is given that there are 2 points A and B and another point C which lies between them, and AC equals to BC. We have to prove that this is given. We have to prove that AC equals to half of AB. Let this is equation first. From equation first, AC equals to BC, adding AC on both sides, we get AC plus AC equal BC plus AC. AC plus AC is 2AC and BC plus AC equals to AB, which is equals to AB. Now AC equals to AB by 2, hence proved. Now the question number 5. Here in question 4, the same question. Point C is called a midpoint of line segment AB. C is midpoint because AC equals to BC. Prove that every line segment has only one midpoint. That is, we have to prove that any line has only one midpoint, not more than one. For this, let AB be a line segment. C and D are two different midpoints. Let C and D are two different midpoints of line segment AB. Because C is midpoint of AB, therefore AC equals to half of AB. Therefore 2AC equals to AB. Let this be equation first. And D is also midpoint of AB. Therefore AD equals to half of AB. Therefore 2AD equals to AB. Now from equation first and second, these both are equals to AB. Therefore 2AC equals to 2AD. 2 and 2 are cancelled out. Therefore AC equals to AD. Now AC and AD are equal if these are equal only if C and D are coincides. Therefore C and D are not two different points. Hence a line segment has only one midpoint.